It's hard for me to let go, but I think that I'm finally feeling good again. So hard cause I loved you, but I'm finally feeling like myself. All of the wounds that were opened by you are now closing. I finally know how to live without hurting myself. I think that I am moving on cause I do feel less broken. I needed a sign, and this is a sign that I'm healing. I'm finally healing from you. I'm finally healing from you. I'm finally healing. Don't mean to come off hardy. I'm just an imperfect person in this imperfect world, but I'm learning my way under this maze that I'm running through. Now when I think of you, I'm fine. See a picture of you, you would eat me alive. And now when I think of you, I'm fine. And all of the wounds that were opened by you are now closing. I finally know how to live without hurting myself. I think that I am moving on cause I do feel less broken. I needed a sign, and this is the sign that I'm healing. I'm finally healing from you.
Hey everybody, happy Blur's Day, Tuesday, right? I just can't spell. Hope you're doing well today. Got a couple things on tap for today we'll take a look at. Just let that finish. There we go. All right. Oh, perfect. We got some ads from when we come back. Maybe put that on mute. Yeah, put that on mute. Play the ads. There we go. All right. Don't forget the Chapter 6 quiz is due tonight. 11:59 p.m. or so. Make sure you get that in before class, or after class. Yeah, don't stop now to take it. Take it after. All right, pull this up here. Take a look at our schedule. This is week 3 already of the summer semester. Holy cow! May is almost gone. We're going to start chapter 8 tonight. That's our second look at classes and objects. We'll spend 2 weeks or so in this chapter, and then we'll get into project 2. So we've got one more week to work on the Powerball project, project number 1. Hopefully that's going well for you. I've got regular office hours Monday and Wednesday from 3 to 4:30 and 10 to 11 p.m. Or by appointment. If you want to try and schedule an appointment another time, suggest a couple times that work for you, and I can try and make one of them work for me. No guarantees, but I'll do my best. And don't forget, we also have study group Thursdays, 5 to 6 p.m. with Mr. Tim. He's fantastic. And you can earn bonus points for your weekly quizzes for attending study group. So I'll get those plugged in when I grade your quizzes there. Sorry, just finishing up my coffee. I thought it was mostly ice at that point. I got a nice iced coffee. All right, so we'll come back to classes and objects. We'll spend 2 weeks there. We'll get into project 2. Got text processing and wrapper classes. Oh, there we go. Now we're back to music here. And we'll just leave that paused. All right. Now we'll come back to Chapter 10, Inheritance. Spend a lot of time in Inheritance. We'll have a project using Inheritance. And then come to Chapter 11. So hopefully you touched on Chapter 10 in 1500. Probably didn't go too deep into Inheritance. But you need to kind of look at that before any of the GUI stuff makes a lot of sense and why we do some of the things the way we do. And then some Advanced File I/O. We'll have our midterm on 7/13. It's a little bit late in the semester, but still a midterm. That's our only exam in the class. And then we'll get back into Java FX GUI programming, chapter 12, 13, and 14. A little bit of extra talk on design patterns, and just some time to work on the final project. And then on 8/17, put that in your calendar. We'll meet together 6 p.m. for a Zoom meeting, and you all can take turns showing off your games. Hopefully you've had a chance to find your learning partner. If you want to make it a trio, that's cool too. I know it was a little tough. I saw lots of posts, so that's great. 2 or 3 is probably fine, and we'll go from there. Yep, and we can work on that final project. Ideally, that's pairs. I'm open to a trio if you guys want to take on more work, but usually the amount of work is the same for a single person or a pair, just because working with another person adds a little bit of extra work to it. It is usually really rewarding, and you'll get a better product out of it, having a chance to talk with other folks and kind of work through those ideas, and you'll spend more time designing and talking about your design instead of just coding. And the more time you spend designing, the better product you're going to get. Because designing your solutions is always worth it, and you're going to get a better result there because you've had a chance to think through it, which is huge. All right, so any questions on the Powerball project before I get started? Just pause a second, get beverage. Hydration, yeah, thank you so much. Hydrate. Especially I heard it almost hit 90 today. It's awfully hot. I'm not really a big fan of the summer weather. I definitely enjoy Michigan and our seasons, and I like the winter. It's always easier to put more layers on, but like when it's 90, you just step outside and you're dripping, and it's awful. But sure, some people like the weather. A hat, you got it, Dusty. You know, I don't actually know what happened to my chess hat. I must have left it in my bedroom, but I got the Mickey hat here. We can go for it. I'm hoping things will get mostly back to normal, and they'll get the June 1st. Yes, yeah, not today, Starborn. Yeah, so we have one more week for that project 1. Ideally, all the projects will have 2 weeks on. I think that's a better pace than a weekly project, because things do happen, and then it gives you a little bit of flexibility there. Although I found, which is, I do it too, if you have a deadline, you don't start working on it until close to the deadline. So the idea of giving you more time so you can start early doesn't always work for me. And I always have people like, oh, hey, the day before, they think they can just knock it out in the day, and then they get stuck and frustrated. And yeah, that'll happen. You're going to be stuck and frustrated if you wait till the day before to try and get this done. So definitely don't recommend you waiting till the day before. But I know that's how some people do deadlines. So all right, cool. So don't forget, I do have all of the book PowerPoints here. I'm assuming you all purchased the textbook, and these have their own copyright notices, so they're for our class use only. You can follow along all the chapters here. It's a good summary of the text, but definitely you should be reading the textbook. Right, that's your main reference. So some of that 8 hours a week that you're spending outside of class working on quizzes and projects is also reading time, right? To read in the textbook, because I can't cover everything when I do lectures. Okay, so I cover the highlights. You don't need my chess there. Well, if you do want to play chess sometime, I am a big chess nerd. Exclam chess there in the chat. We'll give you the link if you want to challenge me to usually a daily game. Those are a little easier to follow along with. Just make a move once a day or so. That's always a lot of fun. Okay. All right, so let me fire up NetBeans. Let's get that moving here. Yeah, software developer, for sure. That link is there in the syllabus. That. The output, you can look a little different. I can show you like what it looks like when I run it. I could do that. And it can be like slightly different, but if you just want like an example of what it looks like, yeah, just give me a minute. So for the individual tutoring link here, pull up the syllabus. We got a link to the Academic Support Center's tutoring site here. We can also go through the OCC webpage for the Academic Support Center, and they've got the links there, but this one will link you right to it. Let's see, somewhere down here. Yeah, the Access Office or Academic Support Center for tutoring here. That's what it is. So here's that page. I'll just link that there in chat for you. And the Orchard Ridge schedule, you can meet with Miss Rika or Mr. Tim. There are amazing tutors for the Orchard Ridge campus here. Mr. Tim does all of CIS, and Miss Rika does pretty much all of CIS, not quite everything. 2818, I think that's the Android class, is that right? But not the iOS class, 2819 or something. I'm still trying to get all these course numbers straight in my head here. I know the ones I teach, and we have a lot of other ones as well. Okay. So you got it there. Yeah. So for the project, I don't have it now. I don't want to pull up the solution I have in NetBeans. I might not have it currently on my computer. But I can post that later for you, Serum. If you want to shoot me an email, that would be great. Edit. I have to go to the edit button. That's obnoxious. Should like always go to edit. Yeah, no worries. No worries. So we're in a loop, like we're asking them, right? Do you want to pick your numbers or do you want to buy some random tickets? Right? So pick their numbers or buy X random tickets. If they buy X random tickets, we need to ask them, do they want to show all of the tickets that they bought or just their winning tickets? So if they say, yeah, I want to buy random tickets and I want to buy 1,000 random tickets, you might not want to see 1,000 tickets. You might just want to see the ones that won you money and say, okay, this one won $4, this one won $7, this one won whatever here, right? So they get to pick which one they want. Then we'll generate the winning ticket and we'll compare all the tickets to see how much the player loses. Now, this is important. The white numbers can't repeat, and you match in combination, not permutation, so the order doesn't matter. So remember, all the white numbers come out of a single bucket. So you have 69 balls in a bucket, and they pick 5 of them for the white numbers. 5. There's my thumb. I can't count to 5. 5 white numbers out of that bucket, so there are no repeats. Okay? And we just keep on looping, keeping track of their total spent, total won, and their net loss. Remember, if they're making money, you did something wrong. Right? The more you play, the more you lose. It is guaranteed with the lottery. Yes, there is a chance you hit the jackpot early, but again, the more you play, the faster you lose money. Okay, if you're not showing a net loss, something's wrong in your program. I can guarantee that. So I can get you a sample output in a little while. I just have to go find wherever I had the old code and pull it up. Okay, so the Powerball ticket, right? If we have 2 different options here of whether or not it's a random ticket or if they want to pick their numbers, we're going to need 2 different constructors. Right? You need a constructor that generates random numbers or a constructor that accepts the numbers. If you're accepting numbers, remember the idea with our class is that a class has Bill 9. Yeah, you know, I've watched Hikaru Nakamura play often enough. I have the mug somewhere with the Bong Cloud on it, back from when he first started streaming. And I've watched some of his openings enough when he did his run to like 2000 or something like that with the Bong Cloud. I picked up some Bong Cloud theory. So it's, you know, it's not the worst. It might be the worst, but it's workable at least. It doesn't put you at that much of a disadvantage. But yeah, for sure. I mean, he's built up enough theory about it now, and they played it in. Him and Magnus played it, right? Didn't him and Magnus play it in the latest tournament when they just needed the draw, and they're like, oh sure. I think that's what it was. It was just a big joke. But sure, I mean, high level chess is nuts. Like, and that's good tournament theory, right? And tournament strategy. If you don't need to win the game and a draw is okay for you, to play something easy, get a quick draw. It's not entertaining for the fans, sure, but I mean, it's good strategy for your tournament play, right? Don't wear yourself out. I mean, take it an easy day if you want to get the draw, and you're good to go. But all right, so our Powerball tickets, right? They have no repeats. So our constructors here take one with random numbers, where you just don't give it any arguments and it generates its own random numbers, and another where you give it numbers. And when we talk about designing a class, right, we've encapsulated all of the details of this noun, the noun being the ticket here. And one of the jobs of our class is to maintain its integrity. The class should not let itself get into a bad state. So when we are given numbers, we should make sure that there are no repeats in those numbers. No, there's no points in the rubric for that, unfortunately, right? Constructor that generates a random ticket, constructor that accepts 5 white numbers and 1 red number. But it should check to make sure there are 5 valid white numbers, because if I give you 1, 1, 1, 1, 1 here, if I give you 5 ones and you just take that, and if the winning ticket has 1 1 in it, your matching logic is probably going to say, hey, you have 5 white matches, which is incorrect, because you've allowed duplicates, and then you're going to get some bad results. That's one of the things that can happen, right? So we do need to be careful. We're going to have our private attributes for all of its values and public methods. We'll have a get winnings method that accepts another instance of the Powerball ticket. The get winning correctly calculates the winnings. And then we're unit testing all of our 9 different ways to win, plus the no winning, right? So 8 ways to win, plus the 1 loss, essentially, where you don't win anything, a no match. Our simulator tracks our total spent, our total won, our net loss, and displays every time. So like, okay, you wanted to buy 100 tickets? Sure, here's your totals. Do you want to play again? Do you want to buy more tickets? Do you want to buy a single ticket, or pick your numbers, random tickets, or just be all done? Whatever. And they just keep on going until they're bored, and then just ask if they want to display all the tickets or just the winning tickets when they buy the random tickets. Here. And that's our points. So this one was worth a couple points. That's a little bit trickier. Not the hardest thing in the world to do, but just a little bit trickier than maybe some of those other things. And then it comes out to an even 20 points, and that makes me happy because it's a nice round number. Okay. So a bulk of the points here are for the tests. Sipping coffee, they called it Java. I don't actually know why they called it Java. There's supposed to be some story about it somewhere. It used to be called Oak, or was going to be called Oak or something like that. It's been a while. It's in chapter 1 of the book, if you actually read the chapter. Mr. Gaddis tells you all about it, because that's what you do in textbooks. You give people way more information than they need. It's a reference, right? I specifically call it a reference for you. That's your reference for how you go and look things up, right? It's going to be the easy place to go find things, because you can find tons of information online, but you're not always going to find exactly what you need, or it might not be applicable to what we're doing. So like all the things that we're doing, you can find how to do them, the tools and techniques we're going to use in the textbook. That's our main reference. Okay, that's going to be the easy place to go look, and he's got it laid out in a nice little. It's relatively readable for a textbook. He does a decent job there with that. You know, if I cut down some of the points, then that's all right. We can leave it at 20. That's all right. Okay. So that's project 1. That's Powerball. All right, and I think my NetBeans's finally loaded. There we go. Close out this other project. Start up a new project. This is chapter 8 tonight. So a Java with Ant project that still haven't got a chance to make the Gradle stuff. And it sort of works, but it's still particular and obnoxious. And, you know, the fact that it has errors, even though it works, upsets me. So Java with Ant is usually pretty good here. We'll call this chapter 8. And I'll make sure I'm going to put it in my repository folder, right? So you can either browse to it, or, hey, thanks so much for the follow. Or just copy paste. Or mine, I know it's 2151. So it's in my documents, GitHub 2151, summer 2021. So all the code for class is going to go into that repository. I pull up my GitHub client. Remember, you can go there and look at it, find it, copy it, You can even clone it yourself and then keep it in up to date. But then if you make any changes to it, it's a little trickier. So I don't know. I don't typically recommend you make your own clones, but you can if you want. And then they'll just open with NetBeans as well. It's kind of fun. All right, so here's the summer repository. And it should say, hey, there's a bunch of new files because we made a new project, a Chapter 8 project. Still making it. Okay, come on, NetBeans. For some more cold medicine. Don't know that number. All right, pull all this stuff out. There we go. All right, and we're actually not going to use this yet, right? Because we're not going to put our own class here. This is just the Chapter 8. This is like the one with the main program in it. Sometimes you'll call it the driver class. This is the entry point for where our application starts, but I want to start a new class over here. Okay, so let's see. What do we want to work on? Let me pull up this here, make sure I'm following along. Okay, yeah, that's fine. We can do that. So we'll do the boring example first, and that's okay. So let's take a look at a I don't know who you had for 1500. I don't know what stuff you covered, so bear with me here. We're just going to do this as a Polygon, okay? So we're going to make an instance of the Polygon class. So right now we're writing the blueprint here for Polygon. And we'll say for Polygon, it needs to know its number of sides. Right, so a Polygon has some number of sides, and then it's going to have an array list of type integer for, we'll say the side lengths. And yeah, NetBeans doesn't know what array list is, so yeah, we need to go add the import. We say, yeah, we want the one from java.util.arraylist. Use the one out of the Java library. Okay? So here's a Polygon class. And we're going to write a constructor for Polygon. So this is a public Polygon. Remember, the constructor has the name of the class here and no return type. And we're going to say, if you want to make a Polygon, I want an argument for your number of sides. Okay, I'll give that a little format. So if you tell me how many sides there are, you can make a Polygon. I don't have a constructor with no arguments because I want to know how many sides are in this Polygon. And once you make a Polygon, we're not going to change the number of sides. Right? So this idea that this attribute is not going to change at all. Then I can say my this dot number of sides equals the number of sides. Give that a little format here. Okay? And it's giving me a little notice here that this could be final, which is fine. Let's make this final. So once it gets set, it can't be changed. It prevents it from changing the code. Remember when you mark something as final, it can't be changed. So this is just to make sure that I don't try and reassign the value number of sides later on by mistake. Okay, optional, but it's a nice thing to do if you don't want it to change. Right? It keeps the code protecting itself. Okay, and then what we can do with the Polygon is we can add a method. This is probably a void method. We're not going to return anything for set side length. So if you tell me the side number, right, we'll say side index, right, and the int side length, we'll set that. But to do that, we need this array list of side lengths to be created. So we need to go through, we need to make side lengths equals a new array list of type integer. And we can even size it to number of sides. Remember, this sizing is optional, but if you do know the number of sides, it's going to size it appropriately. So it's good to do with array lists. They'll perform better if you tell them how big they are. Usually it only matters if you're working with really large numbers, but it's still not bad to do here. And then what we need to go do, right, we need to go give them values. So for now, I'm assuming they're all zeros. So I'm going to say for int side index is 0. Side index is less than number of sides, side index plus plus, and we'll take my side lengths, and we're going to set, nope, we're just going to add, that's right. We're going to add 0. I don't even need side index, that's okay. So we're going to add this many zeros. So for every side that you have, we're going to add a 0. So if this were a basic array, it would default to 0, right? But array lists, they don't default So we tell it it's this big, but it doesn't have that many in there yet, so we need to go add a bunch of zeros. I guess that's the one downside of using array lists, where a basic array, we could just size at this size and it'd be perfectly fine. But I like array lists, so we'll go this way. Okay, so we're going to add in all the zeros for our sides. Then to set a side length, I can take my side lengths and I can set side index to the value of the side length. Did I do it wrong? Oh, side length. There we go. Yeah, it was. I should have noticed it didn't turn purple. Side lengths dot set the side index and the side length. There we go. Now we probably should do some sanity checking here and make sure that we give a valid value. But this is also just going to crash if you give me a bad index anyway, because my array list will just crash and we'll just throw the exception. So this is probably okay. We haven't really talked about exceptions. We should probably do that sooner rather than later, but it's kind of stuck in later near the end, which is unfortunate. But we can talk about that later. All right, so that'll set the side length, and maybe we have a way to get the side length. How about int get side length for the int side index? And we'll return side lengths dot, oh my goodness, side lengths, there we go, dot get side index. So if you want the length of a given size, we'll give it to you out of our array list, right? So this is our set and our get. We don't want to just take the entire array. We don't want to set and get on the array here, on the array list. We want to do an individual side at a time. Okay, and then the other thing we can do with a polygon is we can return the perimeter. Parameter, right? Maybe get perimeter. I don't know. Oops, that's a P. So how about get perimeter? So we'll have an int for perimeter. Starts off at 0, and then we'll say for side in side lengths. Oops, inside, sorry. Inside in side lengths. We're going to take perimeter plus equals the side. When we're done, we can return the perimeter. Right, this will just look at all the side lengths, all the lengths of the sides, add them all up, and we've calculated our perimeter. Right, we okay so far? And again, we haven't really done any sanity checking that this makes a closed polygon. Because if you give me some really weird side lengths, right, it's just going to be, the shape won't close, but that's okay, right? This is just pretend. It doesn't have to be a closed shape in this case. Maybe we'll just have a bunch of sides. And that's okay for now, right? Not too big of a deal. Right, we all right with polygon? So then what we can do in our chapter 8, the main or the driver, here we can actually make polygons. Polygon, maybe we'll say, hey, this is my first shape, equals a new polygon, and we'll say, hey, how many sides does this one have? How about 5 sides on this one? We'll take first shape dot set side length to, so index of 0, let's set to, I don't know, 2, and we'll set a bunch of lengths. How about 1, 2, and 3, and 4 to, I don't know, 2, 3, 4, 5, 6, why not? Okay. And then we can print out the first shape, oops, dot get perimeter. And we should get the sum of 2, 3, 4, 5, 6. Right? So there's a 10, and there's a 10, so it should be 20, right? So when we run this, we should get out 20. Now this is, again, kind of what I call poor man's testing, right? We're having to do it ourselves. There's nothing wrong with that, right? And you do want to make sure code works here, but we could do better with our unit testing. So if we come to Polygon and we actually write unit tests for it, we can make the computer do that work for us. And the computer's much better at it. So I'm going to right-click my class and say navigate, go to test. Yep, let's add some tests. Again, JUnit4, if you're using Ant, is going to work best for you here. Or work. JUnit just doesn't work at all. Okay, and setting side lengths and getting side lengths. Yeah, we could test them, but really I care about perimeter. That's really what I want to do. Because we're calling set to test the perimeter. We didn't do individual gets, so we could do the individual gets maybe. Maybe we'll do a get perimeter or get side length. But the set side length we don't need to test separately because you can't test the get without using set. Sets and gets often come in pairs, and that's okay. So we're going to do our AAA format, right? We're going to arrange, we're going to act, and we're going to assert. So to arrange, we'll set up the things we need. So we'll have an int side length equals 10, and then we need to call the code we're testing. Or I guess we can make the polygon here, right? The polygon equals a new polygon. And sure, how about we just have one side on this polygon? It's just a line, not really much of a polygon, but that's okay. And then the code we're testing, I guess we could put set in here because we were kind of testing set at the same time. If you want to put it up in the arrange, that's fine too. So we'll set side length of 0 to the side length. Actually, let me rename this here. Refactor, rename. We'll call this the expected side length. Okay. And then we'll call a get. We'll have an int for actual side length equals my polygon dot get side length of 0. Sorry, that should be set. No wonder it's upsetting me. Set side length. There we go. So setting side 0 to our expected, and then actually get back out what it is. And we can assert that the equals. So assert equal my expected side length and my actual side length. Do they match? Okay, and then for getting perimeter, we're going to do a similar thing here. But maybe we'll add more than one side. So we don't really need the expected side length, but we'll have an expected perimeter. Expected perimeter here. And if we make it, again, a 5-sided polygon, and then we set them all, right? So we did 5 again. So we did 1 and 2 and 3 and 4. We said was lengths 2, 3, 4, 5, and 6. And then we have an actual perimeter. Actual perimeter is get perimeter. And we can compare the actual perimeter with the expected perimeter. Oh, that should be 20, not 10, right? Okay, and we can run our tests. So then we'll test our file. We'll check our test results here. And we'll see what we get. Right, remember, the computer is going to be better at checking this sort of thing than we are. Right, they both pass. Life is good. We should feel pretty good about this working here now, right, for Polygon. So in terms of code coverage, we ran our constructor, set was called, get was called, and get parameter was called. So we should feel like we have 100% code coverage, right? We didn't really have any if blocks and else blocks that we needed to have other interesting tests for. We've called all the methods. So all of our code is exercised when we're running. Right? Does that part make sense? So this was still all the stuff we did from chapter 6 plus unit tests. Nothing really new here. Okay? So now I want to take a minute and show you another, it's maybe a programming philosophy or idea, a way of programming. It's called test-driven development. It's a fantastic way to approach writing programs. And the idea with test-driven development is you design your solution, you know what your classes look like, maybe you even do some UML, right, where we have the name of the class, and we have the attributes, and we have all the method names. We get some UML down, and then if we know what the classes are supposed to do, we can write unit tests for them before we have any working code. And the idea is we get all of the unit tests down to test all of the functionality that we expect our class to have, and then the funny part is all of the tests fail. Right? The goal is all the tests fail. Because then what happens is now your job is to take this list of failing tests and make them pass. So it helps you stay really focused on, okay, here's the functionality I need to add. Now, it probably hasn't happened to you yet, and that's okay, because we've only done some small projects. Nothing's really all that interesting or exciting. But in the real world, when you work on big, meaningful projects that are actually solving problems for real people, not just solving little puzzles here, there's always other things that can be done. Other functionality, little things that make life a little better, or tweaks, or maybe you want to make the menu look like this, or do this sort of function. And it's easy to take on more than you need to do. Right, and to build out more functionality than you needed to have. We'll call that scope creep, and you'll probably hear about that in the software engineering class. I haven't actually looked too much into that. I gotta take a look at what that class covers and all, but that's a software engineering concept. This idea of scope creep, that we're doing more than we need to do. So with test-driven development, because we're writing the tests based on our design, that this is the functionality we need, it helps you focus on only getting the stuff done that you need to have done. And it's really cool. So what we do is we're going to write a class, essentially a shell of the class, or a stub of the class. So we're going to write the class and we're going to have the methods, but they're not going to do anything yet. So let's write another class here. And let's see, let's come into a new class here. How about we write a class? Let's see. So we did Polygon. How about we do, what did we do last? We already did cups and everything. We did vehicle? I should really look back up what we did. Let me just look it back up because that's what we should do. Oops. GitHub, Eric. Oh, there's too many dots there. My goodness. Yes, 2151. Summer. There we go. So which ones have we already done? All right, we did magic number. We did the autopilot plane. Okay, so we didn't do like a vehicle. Let's do a vehicle class here. Okay, so let's take a minute and kind of sketch this out. Pull up whiteboard. Ooh, that blue is really cool. Got a cool reflection when that's open. Give this a clear. All right, so this idea, if we have a vehicle class here, right, vehicle, it's nice and clear, right? So attributes of vehicle, right? It'll probably have sorry, if we do this UML style, a name, which is a string, right? We'll probably have a, let's say, kilometers per liter, and that's probably a double, right? We got to use the metric system because it's way superior to our crazy imperial units that don't make any sense. So kilometers per liter, and then we'll have a gas tank capacity, and that's in liters, right? In liters. I always like to name my units, and that's probably a double as well. Right, we should make that a little bit bigger, sorry. Like that, double, right, and then we'll have a gas in tank in liters. Again, as a double, so how much gas is actually in the tank. Right, we'll have our kilometers per liter, we'll have our name. That's probably enough for now for our attributes. And then we'll have a public method like drive a number of kilometers, right? So yeah, kilometers, right? Which is probably a double. And then we'll need another method here, right? For add gas. Add gas. And this is, gas as a double. Right? This part makes sense, just kind of sketching out, doing a little bit of UML here for what our class will look like. So this is the vehicle class, has some private attributes, has some public methods, and probably a bunch of get methods that, sure, public get dot, 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 dot. That's probably enough for now. And again, I don't need to list them all right now. You don't need to watch me in my terrible handwriting write some stuff. Okay, so that's what our vehicle looks like. We can go stub this class out, so it'll be there, but it won't have much function. And then we'll go write the tests. Okay? Whoa. Oh, my kids have the hose. I thought it started raining. Didn't know it could spray up that high. All right, so let's go and add a new class for vehicle. Vehicle. There we go. All right, and we said we had a string for name. We had a private double for, this was kilometers per liter, and a double for gas or tank capacity, gas tank capacity in liters, and a gas in tank in liters. Okay, and then we'll need a constructor. Again, it's not going to do anything right now, and then we'll have a bunch of get methods. We can add all the get methods, right, with insert code. add a bunch of getters here for everything. That's fine. And then we needed a void method for drive. And let's make this a Boolean method. Drive a int or double kilometers, right? And then for now, we're just going to return false, because if it has a return type, we need to stub it so that it works. So all the gets work, and then we had drive, and then we had we'll do this as well for the add gas. Double liters. And again, we'll just return false. Okay? So we don't have any working code here for the actual functionality here. So all the gets are going to work. That's fine. Again, we don't really test the gets very much. And the constructor hasn't set them all. Maybe the constructor should take some of these values. So let's do that again. Let's make a constructor that takes some of these. So we take a name, the kilometers per liter. How about a gas tank capacity? We'll assume you start with no gas. Okay? So sure, it has some values here, but we haven't done it all. So it doesn't all work yet. Okay, now we're going to go, before we write drive and add gas here, we're going to go write the tests for them. We're going to go to navigate, go to tests. Yes, we want to create some tests, make JUnit4 tests. We're good. All right, awesome. So we're going to say an add test. Here, this is public void test, what is it, add gas. Okay, and we'll do arrange, and we'll act, and we'll assert. So we're going to have a double expected gas in liters, right? I don't know, 10 liters, how about that? And then we'll make the vehicle, we'll add the gas, and we'll see do we get the right gas back out. So again, depending whether or not you think that should go in act or arrange, that's okay. It's probably all fine to put it in here. So we'll have a vehicle equals a new vehicle. Oh my goodness, vehicle equals a new vehicle. And then it needs a name, right? We don't really care what the name was. A tank capacity, right, should be, oh no, this is liters per gallon, right? Or kilometers per liter, right? Doesn't matter, we can just say 0. And then the capacity here should probably be the max here. We'll make the vehicle, and then we need to add the gas. So we'll call vehicle.add gas, given the expected gas in liters. And then we have a double for actual gas in liters. Here's my vehicle. Get gas in tank in liters. And we can compare, do they match, right? So this is assert equal. And the fun part is, remember, Java is actually really bad at math. So when you have a double and you're comparing doubles, what you're going to give it is a third argument here. Right off the bat, it's going to yell at us here and say, hey, this doesn't work. So what we need to give it is a delta, is how close is enough. So if we say like 0.0001 or 0.0001, it's going to say, okay, are these doubles within 1/10, 100,000th, 10,000, 100,000th of each other? Right? Are they close enough here? When you're dealing with doubles, weird stuff can happen, right? You get like a weird trailing decimal place in the millionth, billionth place or whatever it happens to be. You get some weird rounding errors. Okay, so that's delta here when we compare doubles. So doubles requires a delta, or how close is close enough. Okay, that's what that is for us here. And we can see, does this work? And when we test it, it should fail, which is good. We want the test to fail, so then once we've written it, now we can focus on making it pass. Right? We expected to get 10 back, we got 0 back. We're not getting any gas back out because our add gas doesn't actually do anything. That's right, we haven't made that work. And actually we should have a Boolean result, right? Result is this, and then we should be able to assert true my result. Right? That should give me back a true value. The idea with the Boolean, right, is if we overfilled the tank, we should tell them false, a bad thing happened. That sort of thing. Right? And then again, this should still fail. If any of the asserts fail, the whole test fails. That's why it's good practice to have lots of small tests. You don't want one big test, because it's, trying to wade through and find out which was the wrong one is obnoxious sometimes. All right, so we have add gas, and then we're going to also test drive. Oops, it probably doesn't need 2 S's there. Okay. So Then for driving now, we need to add some gas to the tank, and then we need to drive. And then driving should reduce the amount of gas to something here. Right? So if we get 1 kilometer per liter, and if I add gas, let's do this as, expected, let's do 20 here, and then we'll add 20. We'll add the gas. We don't actually need the result here. We just want to add the gas. We don't need to get the gas in the tank. Now we're going to call drive. So we'll call vehicle dot drive. So if we drive 10 kilometers, that should use 10 liters of gas, and we should get 10 back. So then the actual gas in liters is my vehicle get gas in tank in liters. And is that close enough? And then this should be my drive result. So Boolean result. So this could probably move up to the arrange. Again, we're not really testing this part of it here. Right? What we really care about is the drive portion. Right, so maybe we move this up to arrange. That's fine. Okay, so we add the gas for testing that. This time we're testing drive. If we drive 10 kilometers, we get 1 liter of gas used per kilometer. And we started with 20, right? If we added 20, we should be back down to 10. And again, this should also fail. Take a look at our test results. That one failed, right? That's all good. This test drive, and this, it works, right? It should work. Returns true, maybe that's better. Returns true. I like that. Returns true. And then again, we can do this whole thing again and say we should expect return false. Add gas. Returns. Oh, I changed the wrong one. Returns true. So if we have a tank capacity of 10 and we try and add 20, right, we should get back a false result. So we'll assert false, that it didn't work, but what we should get here is it should still only put the 10 in, right? We'll pretend that like the rest of the gas that's spilled, we don't care. We just didn't go in the tank. It just spilled out all over the gas station, and it was a bad thing, but okay. Right, so if you try and put 20 liters in and you only can fit 10, if your capacity is 10, then we're going to get a false result here from add gas. It didn't work right. Something bad happened. And we should still only have 10 gallons in the tank. And then for driving, right, this is returns false. If we try and drive 30 kilometers, we should have no gas left in the tank. So if we add 20 liters of gas, we drive 30 kilometers, we get 1 kilometer per liter, or 1 liter per kilometer. We drive 30, it's going to be false here. We're going to say, hey, that didn't work, you ran out of gas, and you have no gas left in the tank. We should have 0 left after you've driven on all of it. Right, so that's sort of the what should happen inside of our methods. And again, it's hard to kind of show that in the UML, right? You just have a method. Oh, we should say these are Booleans here, right? So Boolean. And we should also add the constructor, but again, it's hard to fit that all in right now. Okay, test drive returns false. Oh, goodness. So this one works because we're returning false and we have 0 in the tank already. That's not great that this one fails, but it's kind of hard to do anything about that because those are default values. So it's okay. I wouldn't worry too much about that one. But you can see now we have the list of things we need to make work. Okay, so now we'll come to our vehicle class and we'll actually write the logic to make this work. Okay, so we should set my gas in tank in liters to 0. It's defaulting to 0 anyway, but the constructor's job is to give them values, right? The constructor should set all of your attributes. Don't rely on an attribute default. That's bad practice, right? So I know it's a default, that's okay, but don't worry about it. And it's telling us these things could be finals. Actually, the gas tank capacity is final, sure, but the gas in tank cannot be final because this one's going to be changing here. So we won't do that one. But now add gas, okay? So let's check. If liters, let's again do a sanity check here, is less than 0, right off the bat we'll return false. You did a bad thing, right? We shouldn't accept a negative value because that would reduce the amount of gas in the tank, and that's bad. Otherwise, we'll take our gas in tank in liters, we'll add the liters. Then we want to check if the gas in tank in liters is greater than the gas tank capacity, then we should reset. right? If we tried to put too much in, well, that's going to put us in a bad state. My class is responsible for maintaining its integrity. So we'll say, no good. You just have now your maximum, and then we'll return false because you did a bad thing. If that didn't happen, then we can return true. Okay, so if you added the gas and you didn't overfill, then return true. Everything's good. If you gave me negative, or if you overfilled, you're getting a false result. But again, if you overfilled, we're just going to back you back down to your maximum, your capacity. Right? The rest of it just spilled out, sure. So in terms of code coverage, if I didn't have a test that tests for negative here, this line of code will never run. I don't have 100% code coverage. So I should go back to vehicle test now and add another one for add gas. Here. This is a negative value returns false. So if we try and add negative something, we should have 0 in the tank still, and we should get back a false result. Okay, so now when I run my tests here, all of my add gas ones should pass. I should feel pretty good that the add gas method does what it's supposed to do. Okay, I got back good results. They passed. So now my code is checking itself. I have unit test code that's checking the class code to make sure the behavior I expect is there. And that's what unit tests are for. Instead of having to do it in main and to make a person eyeball it and say, yeah, okay, that's what I expect to get back out. Because that's exactly what we did here, right? We said, oh, if I make a polygon and I get perimeter, I should get 20. And I ran it and said, okay, I did get 20. That's the exact same thing that we're doing here, but we're putting it in a unit test form where the computer can test it for us. Okay, so add gas is great. And I should feel good that I have 100% code coverage because I've tested yes, false for negative, I've tested false for overfilling, and I've tested a true for not overfilling. Okay, so now we need to come back and we need to do drive. Okay, so again, we'll say if the kilometers is negative, return false right off the bat. Again, this is defensive programming. The idea is that users are stupid. I hate to say it, but that's a fair assumption. And maybe not even a fair assumption. Maybe it's users will give us values we don't expect because it made sense to them. Maybe? I don't know. When you say drive, I don't expect someone to give you a negative number. But my code should defend itself from being in a bad state, right? Part of maintaining my integrity means I won't get in a bad state, where if you go give me a negative value and I wasn't checking for this, all of my arithmetic is going to be screwed up. Right, because what's going to happen, we're going to say it's going to be, I'm going to have a double for liters of gas used is going to be my kilometers per liter. I'm sorry, the kilometers here, kilometers divided by the kilometers per liter here. So if you're going to go 10 kilometers divided by how many kilometers per liter you get, that's how many liters of gas you need to use. Then we'll take the gas in tank in liters and we'll subtract the liters of gas used. If that went negative, right, if that went to less than 0, we need to reset. We'll say, hey, you can't be a negative value. You're going to be at 0, and we're going to return false. You drove as far as we could. We stopped, ran out of gas. Otherwise, we can return true. Return true. Okay? So find out how much gas we're going to use. Take it out of the tank. If we went negative, that's a bad state here. So if this was a negative number here, and we were subtracting the result. Subtracting a negative is like adding. All of a sudden, they've now added more gas to our tank by telling us they went a negative distance. Right? So we can't let that happen because that could put us in a bad state where our class no longer has integrity. If you say that there's more gas in the tank than your capacity, something's wrong. Right? Because that shouldn't have happened. So we're protecting against that by checking, making sure we don't go negative. Right? Right, then we'll go back and we'll check our tests. Go to vehicle tests, we'll run our tests and see what we get. All right, the tests are passing, but again, I want to add one more for the negative value here. So drive negative returns false. So if we drive negative 30 here, if we've added 20, we should have 20 still in the tank. Right, because nothing should have changed. So let's check our tests. Okay, and now all the tests are passing. So we should feel good, and now we should feel good that we have 100% code coverage, because this if block was tested, this if block was tested, and we got to here. So all of the code in the class has been exercised. We haven't done the gets. I guess we could do the gets. So we'll do one more test here just to finish this out, and then we'll call it a break here. So we'll test our constructor. Test public void, oops, void test constructor. So we'll arrange, we'll act, and we'll assert. So we'll have a string for expected name equals call mine thunder, or no, yeah, call mine thunder. Call my car thunder, and then we'll have a double for expected liters, no, kilometers per liter. Again, it's kind of awkward in my car. It's an electric car, so this whole example is bad anyway. But okay, we'll use the other one. Eugene. We'll use my transit here. And then we'll have a double for expected gas tank capacity in liters. In liters here, what is it? 24 gallons to liters. 90. Okay, 90.8. Okay, so 90.8. Let's say is 90.8, and an expected gas in tank in liters should be 0, because the constructor should set it to 0. So we'll call the constructor. So vehicle equals a new vehicle, given the expected name, given the expected kilometers per liter, and given the expected, or the gas tank capacity in liters. Cool. And then we'll have actuals. So we'll have a string actual name, vehicle.getName. Oops, expected name. Vehicle, I can't type. And a double for actual kilometers per liter, vehicle.get kilometers per liter. I can't type vehicle, my goodness. Get kilometers per liter. All right, and then we'll have an actual gas tank capacity. Sure, let's just grab these. Call this actual vehicle.get tank capacity and vehicle.get gas in tank in liters. And add some semicolons and add some asserts. So then we'll assert equal expected name and the actual name. Good. We'll assert equal. This one is the expected kilometers per liter and the actual kilometers per liter with a delta of, I don't know, something like that. It's probably good. I'll do 3 more of those because I have more doubles. Expected tank capacity, the actual tank capacity, the expected tank gas in tank, and the actual gas in tank. Okay, and we'll run. So now we've tested our constructor, and this one hopefully will pass now. I probably should have written this one first too. I'm sorry. Uh-oh. Expected 90.8, but was 0. Where did I do that wrong? Expected gas in tank, actual gas in tank. Expected gas tank capacity, actual gas tank capacity. Huh. Where does that? Line 30. Expected gas tank capacity in liters, 90.8. Actual gas tank capacity in liters. Gas tank capacity in liters. Expected kilometers per liter, expected gas in tank. All right, did we do it wrong in vehicle? Gas tank capacity in liters is gas tank capacity in liters. Kilometers per liter is kilometers per liter. What did we do wrong here? I feel like that one should have passed. Actual gas in tank. Get gas in tank. Gas tank capacity. Tank capacity. I'm super confused now. Does my get method not work? Get gas tank capacity, get gas tank. Get kilometers per liter, get name. What is going on here? I must have a typo somewhere. Gas tank capacity, kilometers per liter, name. All right, where is my typo? I'm not seeing it. I really need that cold medicine. Let's try it again. Yeah, expected 90.8, but what's 0? Expected gas tank. Oh, oh yeah, I gave it the expected gas in. Yep, I didn't give it the capacity. I gave it the wrong value. Okay, if I tell it how much the tank capacity here, I gave it the gas in tank. This is my fault for using variable names here. There we go. And not reading very well. Now it should pass. All right, and now our constructor passes. Now we should feel better. Let me bump that down. That's getting a little long there. Okay. You folks feeling okay so far? Again, this is writing tests with test-driven development. Okay, so why don't we take a break? We'll take 10 minutes and we'll come back and we'll pick up starting in chapter 8, looking at static values instead of these instant values, okay? All right, I'll put on some more music. I'll take 10. So let's come back, say, at 7:13. We'll go from there. See you folks in a couple minutes. I'm sorry again about the Spotify ads.
That the brothers on the rise now. Endless celebrations all in my house. Levitating now, I'm super duper fly now. London boy, but DC where I reside now. Put the time in while you always yelling time out. If you quit it, cause I know I'm coming with it. You were sitting, you were wishing I was handling my business. Now I got the ball like Harry Potter playing Quidditch. And my business is humongous, you would think that happens in it. Damn man, I'm all that, yeah I'm all that. Looking for that whip, yeah that what you call that. I'ma blow up in the summer, have them yelling fall back. And I've always been ahead like an effing ball cap. Man, I came in the game like whoa. Got a couple chains on me cause I like gold. They told me I'm the best and I told them I know. Cause when I'm in your town, every ticket I sold. Yeah, they saying I'm the man. Facts bro, lot of haters, tell me where they at though. I'm the new pop, all I do is rap though. Want me on your song, throw a couple stacks, yo. Woo! Everybody wanna do the same thing, yup. That's why we ain't on the same page. Do my own thing, and I maintain. Flow like water, so I'm going mainstream. I'm going mainstream. Flow like water, so I'm going mainstream. Yeah, I'm going mainstream. Flow like water, so I'm going mainstream. I'm going mainstream. Mainstream. Flow like water, so I'm going mainstream. Yeah. I'm going mainstream. Damn. Flow like water, so I'm going mainstream. Woo. I'm going mainstream. Flow like water, so I'm going mainstream.
We started out on a Wednesday and I couldn't figure out why you would be mad at me. Whoa, you say it's nothing but it never ever changes, just like that. It's always whatever anyway, every time we try to talk, I am out of here any day. It's always something, no, it never ever changes, just like that. I get the shivers whenever I'm thinking about you. Just wanna leave and live without you. Be on my own again. I get the shivers whenever you go out of line, yeah. I feel the creeping down my spine, yeah. Wanna be alone again. It's almost night time, waiting for the right time. Gotta get this right, I'm scared to death. Scared of your eyes, looking into my eyes. Scared that I'll back out and hold my breath. Wake up one morning and see your face, I can feel it coming back. These shivers are every day. Whoa, I say it's over, I get out of bed and leave, yeah. Just like that, I got the shivers whenever I would think about you. Now that I left, I live without you. I'm on my own again. I got the shivers whenever you went out of line, yeah. Now it's like everything is fine, yeah. 'Cause now I'm alone again.
Alrighty, folks. How you doing? Well, you got a good break, got a chance to go get some more fluids. I am feeling yucky quick. That's so weird. Yeah, went out and got the 2 middle school age kids their shot today. I think just being out, it's allergy season's terrible. So I went and took my meds. I got tons of water here, and we'll see how that goes. Ugh. All right. So we looked at test-driven development. We looked at writing our class, and remember, this is these are instance variables. So each vehicle that I have, or each polygon that I have, has its own set of these values. Hey, Ray, happy Tuesday. So I can make a ton of different polygons or a ton of different vehicles, and they'll all have their own set of values because those are instance values. What we can do is our class could also have static values. So a static value means that it belongs to the class and not the instance. So if we write a class like a bank account here, and our bank account, say we have a private double for balance. Again, I don't recommend you do this with regular doubles. Okay, it's fine. I learned an interesting thing about the stock market and how they treat their values. They actually use integers, but they track the thousandth of a penny as integers. It's just a funny thing. And they're going to run out of room for their integers because of Berkshire Hathaway and their large stock value, because he's stupid and doesn't want to split for no reason at all. Anyway, so we'll use a double for balance. It's not ideal because the rounding errors, but again, we won't worry too much about that. We'll just wave our hands and pretend it doesn't matter. And then maybe we'll have a string for the name, and then we'll have a private int for the account number. So these all belong to the instance of bank account. But what we're going to do is we're going to have a static value here. So we'll have a private, private static int next account number. And we'll say it starts off at 1. So a static account number, next account number, means it belongs to the bank account class itself, not to an instance, because static means it belongs to the class. Instance values belong to the instance. So then we could write a method like public bank account, a constructor. Here, you know what? Let's let it do the work for us here. So we'll write a constructor that takes a name, and it's going to start off at 0 here. So it's going to take the name, and then we'll take the account number is equal to the next account number, and we'll take next account number plus plus, and then we'll take balance and start that off at 0. So this one here is using the static value, and then it's going to increase that static value for all the instances of the class. And then let's add an override method here. Override a public string toString method that returns the bank account name. So we'll do string.format, and we'll say, I don't know, the name and then a string substitution for name, and then a balance, I don't know, or account number, and then an integer substitution, that's D for digits, is how I remember that one, and then a balance of dollar, and then a percent. How about 0.2f, so we round to 2 decimal places, so we're showing pennies for balance here. Right? And then we'll give it the name, we'll give it the account number, and we'll give it the balance. So this way we can represent an account as a nice string. Remember, this is the toString override. We get this nice override compile time checking to make sure we did this right, we didn't screw it up. So then the account name probably could be final, account number could be final, sure, we could make those. Balance, and we should be able to public. Let's do again, probably I like booleans. It's not, once we talk about exceptions, we'll look at better ways to do it, but for now boolean's probably okay. We'll do a deposit, a double amount, and then if our deposit, or if our amount is less than 0, just return false right away. Right? No good, game over, you did it wrong. Otherwise, take our balance plus equals the amount, and then return true. Okay, and then how about a withdraw? Boolean withdraw, a double amount. Again, if the amount is negative, return a false right away. And then if the amount is, here we can do that. We can just, if it's less than 0 or the amount is greater than the balance, amount is greater than the balance, here we'll return false. So if you ask for more than your balance or you ask for less than 0, we're going to return false. Otherwise, we'll take our balance minus the amount and we'll return true. So in this case, like the gas example, it just spilled over the floor. Sure, the car itself's not affected. The gas station will care, but the car itself isn't affected. In this case, if you try and withdraw more, we're just going to not do anything at all and not change. So again, we would put this in unit tests and test that sort of thing. But now let's go through and use it real quick. We'll take a look and we'll make a couple bank accounts. So we'll have a bank account. We'll call this our savings equals a new bank account. So this is our savings, and that's all we had to tell it, right? And then we'll have a bank account for checking equals a new bank account. This will be the checking account. Oops, did we do it wrong? Is it not a bank account? Bank account. Am I spelling it wrong? I am spelling it wrong. Oh my goodness. 2 C's an account? Hey, Snake, how you doing today? Good to see you. All right, and then let's just print those out. So we'll print out savings, and we'll print out checking. Okay, and give that a little run, and we should see they get the correct account numbers. So we expect savings to have 1 and checking to have 2. Right, because when that class is loaded into memory, it sets number 1. Yes, teaching's going well, Snake. Hey, so I did actually get this an email here. I meant to post it. Good reminding me here. So I got this from someone. I had no idea if they were legit or not, but then my discipline chair, Miss Madison, over at Auburn Hills, forwarded it on here. So I'm assuming she must know this person or something, because they said they got my name from OCC. So this help desk technician for data services, I have no idea who they are. It came from some recruiter looking for awful shifts. Oh no, those are shift premiums. Okay, so that's not too terrible. Looking for people with some basic IT knowledge here. They're out in, oh shoot, where do they say? Sterling Heights, Michigan. They're looking for somebody. So I'll post this over in the Discord. So thanks for reminding me. I should do that real quick. Thanks. So I'll put that in the little career info spot here. That's worth posting, I guess. So give me just a second, I'll post that. So I try and put that stuff if I can find it. I wanted to make sure it was legit before I passed it on, and apparently Miss Madison, I always forget how to pronounce her name, thought it was, so I'll call that good. I don't know what's in my downloads. Let's put that in the other screen. There we go. All right, so I put the little PDF out there and then her email. So sure. And if that's something you want to look at, great. And then I think my buddy over at UWM said he posted a thing on LinkedIn. There's also a cool looking business analyst training program that they'll hire you into. And I'm sure if you have some sort of IT background, that is even more of a bonus to get into their business analyst team. So check out, that's the other link that's in there right now in the Discord channel. And if you folks find anything good, or find a company that interns or had a good experience or a bad experience, please feel free to share that. It's definitely a good way to build out the network here and help each other out. And then as I know more people, places, it's easier to get people connected, because I can say, hey, this is also a student of mine. I'm always happy to make those connections. So that's a great opportunity, I think. Man, so thirsty. This is crazy. All right. So back to where we were here. Oh, I should commit while we're here. This is from Chapter 8 examples. Again, the idea with static is that it belongs to the class. You don't need an instance of it to create it. So you don't need an instance of bank account to have a next account number, because it belongs to the class level. So when the Java program runs and it loads the bank account class into memory, it sets the static value to 1, and then it can be used when we make instances using the constructor here. Right, the other thing you can do is you can have static methods. So far, like deposit and withdrawal, these are not static, they're instance methods, because you need an instance of the bank account. So in our case, I don't think there's a good method that would be able to be static here. But let's see. Maybe we make another helper class here. We'll call it Math Fun. And in our Math Fun class, we can add static methods for doing some silly math stuff. So we might make a public double get circumference given a double radius. Make that static, sorry. Public static double get circumference given a double radius. And we can return the radius times math.pi. Times 2, right? Pi d. So radius times 2 times pi. Times 2, oh my goodness, hit the right number. Times 2 times pi. Sure. And maybe a public static double get area given a double for radius. Now this one is radius times math.pi. Remember, we can use this math pi constant here. And then what we need, so you don't make an instance of math fun, you just say math fun dot, and you can get area or get circumference, because that is the method defined. This is a static method, so it's class name dot method, because they're static methods, right? Versus the bank account here, right? We would say it's not bank account dot, and we get nothing. Right? There's nothing there. But the instance of the bank account, like savings dot, and we can call deposit or withdrawal. We could deposit some money and let's put $50 in the savings, and we'll go to checking.deposit, and we'll put $100 in the checking. So then if we wanted to get the area, maybe we'll say area of a circle with a radius of 4, right? And then we'll just append in here mathfun dot get area given 4. So 50, oh, I guess we should add a space there, right? That looks a little silly. But 50.26, so 4 squared is 16. 16 times 3 is going to be 48 plus the little bit more. That's probably pretty close. I think our math looks good there. Again, it's kind of silly for us to do this eyeballing here when we can make a unit test to do it. But again, writing the unit test does take a little bit more time. So what you get with unit tests, right? One of the other reasons they're fantastic is that when we write code, it's going to be wonderful and fantastic because someone's paying us to do it, and that code is likely going to live and be used longer than we're around maintaining it. And then maybe someone's going to come along and say, hey, you know, what'd be really cool is if we could do this one other thing, and we had to change it a little bit. So if we have unit tests, when we go to change our class and we change some of the functionality, we add more functionality, you can rerun all of the unit tests, and you should feel pretty good that you didn't break anything inadvertently by making changes. And so maybe we were to make some changes to vehicle and, I don't know, add in some other features here. I don't know what we'd be doing. If we screwed up something about our liters or our gas management here, our unit tests for drive and add gas would fail if we inadvertently did something. Or maybe we renamed a variable badly. Right? The unit test would fail, and that would catch it, and we would find out quickly that we screwed that up. If we don't have unit tests, you're probably only testing and really looking at the thing that you're changing. So the unit tests give you better coverage and a better feeling for I didn't break anything else inadvertently when I make changes to this class later on down the road. So it's a good habit to have, especially for code that is going to be used for a long time in a production environment. Shoot, I'm losing my network connection. What is going on, Comcast? What is that? Inspector. What's happening? Okay, now it's coming back. It's crazy. Look at that big dip. I don't know, what's up with that? I don't know. Can you zoom in? Last 5 minutes. Yeah, there's a big dip there. Shoot. 7:30? Let me see if the kids are doing anything. All right, it's back again. It's so weird. Yeah, unstable. Go figure. Go figure. All right, I think it leveled off. I don't think my kids are on Zoom or anything, so I didn't answer right away. Maybe that's a good sign. All right. So let's take a look at this. So let's go back to our Chapter 8 method here. So maybe, right, maybe we wanted to make this a little bit more interactive. So maybe we wanted to say, use a scanner keyboard equals a new scanner given system.in. And then we'll say how much did you want to deposit in your checking. And again, I'm not a fan of the next int or next double. I think you should always parse it because you have trouble with those methods if you then want to get next line, because it leaves that enter key on the buffer. I have to explain it like every time to 1500, and I just tell people avoid it because it'll make life easier. So we'll have a double for deposit is double.parse double. That's double, parse double, given the keyboard.next line. So get the line, turn into a double, we're good to go. And then we can take the checking.deposit, and we'll deposit the deposit here, and then we'll do the same thing and say for your savings. And then we don't need to redeclare the double. We just say, hey, give it a new value here, and then we'll do the savings.deposit, the deposit. Okay. All right, and that's pretty good. Right, so we run this. It should ask us how much we want to do. So we'll do 50 and 100. We get a balance of 100 for savings, 50 for checking, life is good. But I feel bad because I have the same code in here twice, right? And anytime you have duplicate code, you should feel bad about yourself. That's a good rule of thumb, right? If you learned that one in 1500, maybe not if you didn't have me, but that's okay. You should feel bad about yourself if you have duplicate code, because it means you can do better, right? We did more work than we needed to, so let's turn this into a method instead. So let's write a method here. So public void, I don't know if we'll call this deposit. And what we need then for this deposit method is, or I don't know, ask for deposit. Oh, ask for deposit. Oops, sorry, that should be lowercase a. Ask for deposit. We need an account. We need a bank account argument. We'll call account. Right, and maybe a string for name. No, we don't even need the name, right? Just a bank account. Okay, and instead of doing that here, we're going to do this. I'm going to cut that one out. We'll get the scanner in the method here, I guess. Sure, that's fine. And in your what? In your plus account.getName. Account.get. Do we not have a getName in a bank account? Oh, I didn't add a getName. Oops. Okay, I didn't add any of the gets. My mistake. So insert code, insert some getters. Let's insert all the getters, but not next account number. We don't need that one. So balance, name, and account. Account number, good. So now we can call getName, account.getName, and then add in that question mark. Sure. All right, that's not the ugliest print, but that's not the cleanest one either. And then we'll take account.deposit. So then we can say, hey, ask for deposit. Ask for, oops, sorry, this has to be static. Public static void. Ask for deposit, because this is in our main here. So ask for deposit with the checking, and ask for deposit with the savings. Now I don't feel bad about myself, right? I got rid of my duplicate code. So you can pass objects as arguments here. Now remember, anytime you pass an object, what's actually happening behind the scenes, right? If we go back to here, when we say account, or what's bank account, account equals new account, new bank account, sorry. Account. Right, with whatever arguments. What happens is Java says, oh, you need a place to store a bank account. And it looks at all the instance values in bank account and tells the operating system, hey, I need room to store a string for name. I need room to store a double for balance. And I need room to store an integer for the number, the account number. The operating system will go give Java some place to put these. Again, it'll tell it what name is here in a minute because it hasn't actually gone through that. But what it allocates here for string name is a memory address, right? So you get room to store a memory address. X00000 to start. It'll store a memory address somewhere. So that is actually stored, I don't know, like X32FA. Sure. Remember, memory addresses are done in hexadecimal for whatever reason. The double here then, sure, it's going to put, I don't know, X792B. And how about the account number at X1234? Why not? So Java will go out and reserve locations to store some value. So yeah, here. So we'll actually store, I don't know, I don't know. Sure, it puts that at X32FA. Sure. So when you create an object, Java goes out and asks the operating system for memory to store all of the attributes. Okay, and this here then is stored at some location. I don't know, wherever that happens to be. So all of this, right, is inside of the account at X329B or something. Sure. So at 32X9B, we get a memory address for the string for name. We get a memory address for the double. We get a memory address for the number. Right? It might or might not store them contiguously. We don't actually care. That part doesn't matter. It just knows where to go find it. Right? And then when we assign name, so then the string name, like checking, goes out to somewhere else like X3112. Sure, why not? And then this value is stored at that address. Remember, because a string is an object. So what the string stores is the location of where the string is in memory. And this is quote checking, because it doesn't know how big it is when it starts. Right? Double and balance as primitive types actually get stored at this location, 0 and 0 to start. So we'll write a 0 at this memory address. We'll write a 0 at this memory address. At this memory address, we write another memory address, and that memory address has the actual string. It's kind of a little silly, but that's okay. We don't mind. So what we're doing when we're passing the bank account here to that account method, we're passing a memory address. We're saying, hey, you can go get the thing called account here, call it account, at this memory address. We're passing a reference to our object. And once you have a reference to that object, you can call any of the public methods. What we can't do is reassign it. I can't say, hey, account equals a new bank account, given, I don't know, I stole your money. Right? Because what happens here, it just says, hey, create a new bank account in memory somewhere. And then it says account you point there. So the account that we handed in that method here for deposit, right, the deposit method here gets handed this memory address. So we hand it x329b, and then we call that account. And when you say account equals a new bank account, it says, oh, sure, account, you now store another value. So account is actually a variable, and it's not changing what's stored in account because we passed it the reference. So, Miad, do you know, it turns out it is impossible for pirates to recite the alphabet. They've tested all sorts of pirates, and they always seem to get lost at sea. So they never pass kindergarten, and they never learn the alphabet. Almost crow. They get stuck at R. Yeah, they run out of breath at R. Yeah, I also read another one. It's not really a dad joke, but I thought it was really interesting. They said what actually is happening all the time. That one wasn't recycled from the first lecture. I didn't use that one, Bill 9. No, that one was new. What's the favorite letter is the one I told before. This is they can't recite the alphabet. But turns out humans actually have a life expectancy of 10 minutes. It just turns out breathing resets the clock for you to another 10 minutes every time you breathe. That's just your fun thought for the day. It's not really a dad joke, but just one of those funny thoughts. I don't know, sort of fits the theme, right? Okay, so this method here, this is not going to be able to change the account we pass it. Because what it's doing is it's changing the value of account. So if we deposit 50 and 100, we still have 50 and 100, right? Because it is changing the account value. It's not changing x329b in memory. It's saying, hey, I have a variable that points here. Now my variable points somewhere else. So it's kind of this funny process. When you say that's new, it no longer points here. It points to, I don't know, x92fa. I don't like computer science jokes. I don't like them one bit. That's like the joke. There's 10 kinds of people in the world. Those who understand binary and those who don't. There's a good binary joke for you. All right, so you can pass objects as arguments. You can even return objects as arguments if you wanted. So what we could do if we wanted to return a type of bank account here, we could then return account. Now we're able to steal their money because I'm going to give you back the reference to this new bank account that I just created for you. So if we said savings equals ask for deposit, that should be checking, equals ask for deposit checking, and savings equals ask for deposit savings, then we would have just stolen all their money. Because the other account's going to go away. 50 and 100, and now it's gone, we stole all your money. But as long as we don't take that value back here, right, if we just call the method, it's going to work. So again, it just sort of depends on what you're trying to accomplish here. Right, so you can return or you don't have to return. This is methods with objects. Eight Bytes walk into bars, bartender says, "Can I get you anything?" And they say, "Yeah, just make us a double." Crow, you get like 50 bonus points for that nerdy joke. Unfortunately, the bonus points aren't actually worth anything, so, you know, good luck. Okay, so next we're going to take a look at the equals method. So we've seen, and hopefully you saw before in 1500, if you say, does this string equal this string, it will usually fail, because what equals compares is memory objects. So if I make two accounts, we'll do another bank account, another savings equals a new bank account, we'll call it savings, and then we'll ask for deposit for the another savings, another deposit, another savings. Here, we'll stop that too. If we put the same amount of money in them, and then we say, oops, I forgot. I can't even spell deposit. How much money do you want to deposit? Deposit. My goodness, friends. Okay, and then we'll check. We'll say savings equals another savings. And you know, I'm going to put all this in quotes here. We'll say savings equals another savings, colon, plus the result. We can concatenate that result. No, we can't. Oh, parentheses. Sorry. If I do parentheses here, it should evaluate that equals first. There we go. So sure, we put 50 bucks in, 50 bucks in, 50 bucks in. They're false. They don't, oops, I typoed, but all right, let me rerun it. Make sure I actually type 50 each time. It's going to be false. 50, 50, 50, because they are not the same memory address. What equals checks for objects, right? What equals checks for objects by default is, do they have the same memory address? Remember, because it actually gets this equals definition from object. Everything inherits from object eventually. Remember, implicitly, everything is an object. So like if I say savings dot, remember, I get a bunch of methods that come from object, right? It comes from the java.language.object. It's using this equals check here, which has no idea what to do here. Okay? So what we can do is instead, we can go to bank account and we can write a method called equals. So public boolean equals bank account other. And I think we want this at override, right? Override. Is that right? Shoot. We do it as object. Will that work? Equals? Oh, shoot. Yeah, what's the hash code? We're not going to get to that yet. Okay, well, let's forget that for now. Forget the override for now. We'll just even equals method given a bank account. We can get to that hash code later. Okay, so how do we compare one bank account to another? We should return whether or not my account number equals the other dot account number. If you have the same account number, you're probably the same account, right? You can define your equals method any way you want to. So for vehicle, maybe the name has to match. Right? We probably, again, you would use some sort of identifier like your VIN, that sort of thing. Or for Polygon, if your number of sides match and all the lengths match, right? You can define it any way you want to of how you say that this object is equivalent or equal to another type. Then what we can do is, instead of checking that, we can say, actually, let's do this. Let's do dot equals another savings. Savings dot equals another savings. So 50, 50, and 50. Still false, right? Because they don't have the same account number. So for overriding, it has to be type of object. And you can do that. It's just a little bit obnoxious. We'll get to that later on, how we can override that, but we don't need it for a while. Okay, so right now our account numbers don't match. Right, so we're not equals. So let's go in here and let's break this. Let's do a bad thing here. So I'm going to put a breakpoint in, again using the debugger. Right, and I'm going to go and we're going to debug our file here. Actually, let's put it up. Yeah, that's fine. I can put it here. I'm going to debug from here. So before this line of code runs, we're going to debug. And it's going to pause when it gets to here. So it's going to ask me for a couple things first. It's fine. Where's my output here? So deposit 50, 50, and 50. Now it pauses. Now I get my debugger. Okay, so I can see my variables. I can see I've got my savings, my checking, my another savings. So I'm going to go to another savings and savings. So the account number is 1 for savings. The account number is 3 for another savings. And in the debugger, you can change these suckers. It's really cool. So I'm going to change the account number to 1. So I just click on it and change it to 1. I'm going to change my balance to like $1 million too, because why not? Right? Because I'm running it in debug mode. So now I'm going to do my step into, because I want to see this method run. When I step in, oh, I don't want to step into print line though. Shoot. Let's see. Step in again. Yeah, I don't want print line. So let's step out of that one. Oh, I should have stepped over. Sorry. Hey, Blaziken, it's going pretty well. How about you? But we'll see in our output here now that they equal true because we changed the account number to match. And we can do that sort of thing in the debugger. You can see what the values are. You can even change them if you want. It's really fun. So the debugger is pretty awesome. Okay. So adding your own equals operator is really handy. Because that way we can check, should these things be equivalent instead of are they the same memory address? And again, it sort of depends on your object, right? If you want to be able to compare them that way, great. If you don't want to compare them that way, then don't. That's okay. All right, we okay so far? How's everyone feeling? All right, this actually takes us about halfway through chapter 8, which is pretty good. I don't want to go too far, too much at a time here. So, maybe we could speed it up, but it's a lot of information in chapter 8 once we get to this equals method here. Okay, and I want to leave you a little bit of extra time for working on the Powerball project as well. Because I don't have office hours today, but I can hang out, chat after class, or during the rest of class time if you folks are interested, a little more one-on-one or that sort of thing. But I think it's probably a good pausing point here. The next topic takes a little bit more time, so it would take us probably a little farther than we want to get. And so next week, the first thing I'm going to do at 6 p.m. on June 1st is go over the solution to Powerball. So again, I can't take the projects late. If it's only partially done, that's okay. Turn in what you have, right? Because there are partial points, right? Everything gets graded according to the rubric. So if you go take a look at the rubric for project 1, you get points based on either you did this thing or you didn't do this thing. And if you did it, but you did it wrong, sometimes there's partial points there as well. Okay, so having a constructor that takes a random ticket for Powerball class, 1 point. A constructor that accepts the numbers, the 5 white and 1 red number, great. Again, this one should check and make sure that the 5 white numbers have no duplicates. If you don't do it, it's okay. I didn't explicitly ask for it, but like that, a class should protect its integrity. That's part of what good object-oriented design is all about, is that the class is protecting itself from getting in a bad state. Private attributes for its variables, public methods, great. Get winnings, that accepts another instance of the Powerball ticket. So just having the method, you get 1 point. It actually doing the right thing gets you another point, right? So there's obviously some partial points here. Unit testing, all your ways to winning and not winning at all. So if I make one ticket with one set of numbers and I make another ticket with another set of numbers, I should know what I expect to win, and I can put that in a unit test, right? And say, hey, my expected winnings should be this or this or this. If this ticket get winnings given this ticket, right? So you don't need to unit test anything with the random tickets here, because it's just not going to happen. But we can unit test with our constructors, where we give it the numbers and we know exactly how much money we should win based on what the numbers are. And then the simulator tracking, just looping until they're done, and then whether or not we can properly display the winning tickets or all of the tickets when we buy the random options. Okay? Does that part make sense? So again, partial points are available. Get it in by 6 p.m. on June 1st. There is study group Thursday from 5 to 6. Definitely encourage you to go to study group, and it can even earn you a bonus point. I'm not going to have a quiz this week on Chapter 8. I'll post it next week once we finish up Chapter 8. Yeah, this is all based on Chapter 6 stuff and unit testing. You shouldn't need any of the stuff we're talking about in Chapter 8. Yeah, so the next project will use all this stuff from Chapter 8 once we finish it up next week. So next week, I'll talk about the Powerball project. I'll show you my solution to that, and we'll finish out Chapter 2, we'll finish the second half of Chapter 8, and then we'll talk about Project 2 all next week on June 1st. Okay? Then we'll have text processing wrapper classes, and then the Project 2 solution and inheritance, another week on inheritance, and then the Project 3 solution, talk about exceptions, advanced file I/O, the new project, finish up exceptions, advanced file I/O, we'll have the midterm. Project 4 probably won't be due until 7/20, in case you want more time to study for the midterm, that sort of thing. I'll give you a practice midterm, so you'll feel better about that. We've got time kind of doing 2 weeks on this chapter here. Okay? And then once we talk about exceptions, we'll know the right way to do all these things. I'm really sad that it's in Chapter 11, and maybe I'll switch around how this works, but jumping around sort of confuses people, I found, so I tried not to do that if I can help it. Right, and then after the midterm, we'll go all Java FX with the final project. Get some time to work on it. We should be in good shape. So again, hopefully you found a learning partner, posted on the forums there, found somebody to buddy up with. If it needs to be a trio, that's okay. If things didn't work out right, we can work with that. And then when it comes to the final project, ideally you're going to work with your learning partner in pairs. If you're in a trio, I'm open to that idea, but I'll give you additional things that your project has to do. Okay. Because having a third person then, there's just not enough work on the original project. It's really designed for one person or a pair. And working in pairs doesn't even really save you that much work because you have the additional collaboration, coordination type of work. But given our remote learning, I'm not going to require you to work in pairs like I usually would. But it's a really good experience. Definitely recommend it. But if it doesn't work out, that's okay. Not too big of a deal. Okay? Any other questions, thoughts, concerns? All right, if not, we can probably call it an early night. Take a little bit of time to start working on that project in the Powerball class and the unit tests. All stuff from Chapter 6 and the unit testing we've talked about. Cool. So let's see who else is around on Twitch. Oh, why is my caps lock on? And we'll go raid somebody. Yep, here, let me put on the ending scene here. The screen capture gets super funny if I turn Twitch on and it just freaks out. So let's see who's around we can go bother. Let's see. I don't know if we can actually raid that channel. Let's try that one. They're doing a cool lecture on distributed systems. So sometimes people turn off raids when they're teaching. But yeah, we can't raid, so I'll just do a little shout out here. Yep, so we'll just end. You folks take care. You can go check out Lindsay Cooper. They're doing a really cool lecture on distributed systems for their CSE 138 course. So folks take care, and drop by my office hours. Shoot me an email if you want to schedule an appointment for another time, and we'll go from there. See you folks later.